we started talking about some other things that can happen with our sine and cosine graph. And what we were looking at specifically was a phase shift that shifts our graph left and right. And the thing that caused it to be shifted left or right is if you're adding or subtracting something to your x, which is like what we saw in algebra. Because it's not as simple as algebra, like just moving one to the right, it changes all those x value points. What we did is set up an interval to help us get all of our correct points. So you have to have the interval whenever there is something added or subtracted with your x, but you could do the interval on every problem. Okay, we weren't doing it on the first ones because it wasn't really necessary, but if you did, it wouldn't give you the wrong answer. It's just going to confirm everything that you were already doing. So when in doubt, we'll set up the interval. The rest of it is the same, and that's the nice thing about graphing these trig functions, is we're doing the same things over and over and over again every single day. So first question I always ask is the amplitude. Where do you look to get your amplitude?
The sine or cosine.
So this would be an amplitude of 3/2. Period. How do we find the period?
Don't you take the 3/2 so that divided by 2?
Close. It's the coefficient of x. So normal period of sine and cosine is 2 pi. So we start with 2 pi. And then we divide by the number in front of x. So 2 pi over 2 is pi. Count by, we do our period and divide by 4 for the 4 quadrants. And then what else do I need on this problem? Interval. So the interval we set up the same way every time. We say 0 less than or equal to the argument less than or equal to 2 pi. The argument is the thing we're taking sine or cosine of, so my 2x minus pi. And I'm trying to solve this, so I just have x in the middle. So what would we do?
Add pi.
Pi less than or equal to 2x less than or equal to 3 pi. And then we
Divide by 2.
So pi over 2 less than or equal to x less than or equal to 3 pi over 2. Alright, so now we can draw our graph. My first point is going to start at the beginning of my interval, which is pi over 2. And I'm counting by pi over 4. So, for spacing purposes, saying pi over 2 is like 90 degrees, pi over 4 is 45, so this will be a smaller. We need 5 total points here. And how do we get those points? We add our count pi. So this, you can use a calculator, just don't put in the pi's, or we can think about it. Pi over 2 is like 2 pi over 4, plus 1 pi over 4 would be 3 pi over 4. Plus pi over 4 would be 4 pi over 4, or pi. 5 pi over 4, and 6 pi over 4, which is 3 pi over 2. Okay, my amplitude was 3/2. That's like a 1.5. We are graphing cosine. Where does cosine start? At 1. But in this case, we would start at our amplitude. So when pi over 2, that's the first point in my interval, that's when I should be at my high point of 3/2. My next one, we're down to 0. And we go down to our low point, negative 3/2. Back to 0. Back up to 3/2. And notice the last point of my interval is the last point that I had here. So we have the cosine graph now we're drawing in. Please make sure, oh my goodness, hold on, drawing today. These are curves, so no straight lines. I did ask for 2 periods in the question. How do I get the second period? Yeah. This is my starting point. We need 4 more after that, and you just keep adding your pi over 4. So this is 6 pi over 4 plus pi over 4 is 7 pi over 4. Plus pi over 4 is 8 pi over 4 or 2 pi. 9 pi over 4. 10 pi over 4 or 5 pi over 2. And so then we just continue our pattern. Is that okay with everyone? So let's do so we can also take our graphs and move them up and down. So let's graph y equals 3 cosine of 2x with a minus 2 on the end. All right. All the same things. So start out. What's my amplitude?
3.
Period.
2 pi divided by 2.
2 pi. Count by.
Pi over 4.
Do I have to do an interval on this one? It's not necessary, but I keep telling you you could do it at any time. Let me show you why. So we would just say 0 less than or equal to, what's my argument?
2x.
So to get x by itself, we divide everything by 2. So we get 0 less than or equal to x less than or equal to pi. So you can always do an interval. This tells us we're just starting at 0 like normal, but we should end our first period at pi. The other thing that we have on this one, there's a minus 2 on the end. Think about transformations in college algebra. What happens if you subtract something on the end?
You have to add it to the front.
How does that move your graph?
Right. Flips it over probably, I think.
That's when there's a negative on the x. What's the minus right there? Down. Yes, sorry, minus 2. So this one will go down 2. All right. Good news is that is the last weird thing I can do to these graphs. Okay, so no more tricks. This is all we can do. We are starting at 0. A total of 5 points. We're counting by pi over 4. So 0 plus pi over 4 is pi over 4. Plus pi over 4 would be 2 pi over 4 or pi over 2. 3 pi over 4, 4 pi over 4, which is just pi. And notice that's where we said our interval should end. Okay, let's talk about this down to. So there's different ways you could do it. You could graph your function and then do your transformation, move everything down 2, which is kind of the strategy in college algebra, and that still works. It can be a little confusing on these because when we get into some of the other trig functions, we have asymptotes, and so if you're trying to do a parent function and that, it can put a lot of information on your graph. So here's what I like to do. We're moving our graph down 2, so I'm going to go to -2, and I'm going to draw in a dashed line here. This is going to represent my center. So when I move my graph down, it moves my center of the graph. And remember, sine and cosine are just bouncing back and forth across that center line. This one had an amplitude of 3. So that means we could go 3 above this line. So my highest point will be at +1. Or we can go 3 below this line. So the lowest my graph would hit is -5. We are graphing cosine. So we're going to center my whole graph around this blue line. Where does cosine start? Starts at its high point. Since my amplitude is 3, I will start 3 above this line, which is at +1. And then cosine comes back to 0, but 0 is not the x-axis, it's the center line. Then we go 3 below it, back to 0, which is the blue line, and then 3 above. Everything else stays the same, but we're just going to, before we actually put in our points and draw it, we're going to draw in the center, wherever that is, and then we're just oscillating around that middle line. Let's try another. This one is written a little bit differently, but keep in mind, if I have 4 minus that, isn't that the same as if I wrote -2 sine of 3x minus pi with a +4 on the end? So what's this 4 going to do? And we have a negative in front. What's that do? Amplitude. Remember, amplitude is the coefficient, but it's always positive. So this would be an amplitude of 2. Period is 2 pi divided by the coefficient of x, which is 3. Count by is your period divided by 4 for the 4 quadrants. And you can do it on the calculator, do your 2/3 in parentheses, and then do divided by 4 and put it back in fraction form. You get 5/6, I think. Do I have to do an interval here? Yeah, you have to if there's anything added or subtracted to the x. When in doubt, just always do it. It won't hurt you. So interval, we say 0 less than or equal to the argument, less than or equal to 2 pi. So if I'm going to solve this for x, we add pi to everything, and then we divide by 3. So we get pi over 3 less than or equal to x, less than or equal to pi. Okay. My first point will happen at pi over 3. And then I'm counting by pi over 6. So it's like 1/3 or 2 over 6 plus 1 over 6. So 3 over 6 or pi over 2. Plus pi over 6 would be 4 pi over 6, so 2 pi over 3. 5 pi over 6 and 6 pi over 6, which is pi. This graph is going up 4. So I'm going to go to positive 4. And I'm drawing in this new axis, essentially. That's the line we're going to go above and below. My amplitude is 2, so my highest point would be 2 above that, which is 6. My lowest point would be 2 below it, which is 2. So then, we are graphing sine. Sine starts at its center. So when pi over 3, the beginning of my interval, we should be on this blue line here. That's my center. Then sine goes up. But what else did we say we had to do to this graph? We have to flip it. So instead of going up, this one will go down first. The amplitude is 2. So at pi over 2, will be 2 below this line. 2 pi over 3, we're back on the line. And 5 pi over 6, we go 2 above. And pi, we're back on the line. So it should look like this. If I ask for a second period, what do you do?
Continue it.
Yep, just add more points. Alright, is this okay? So, I want to give you guys a lot of time to work. So I'm stopping here. So Friday, I gave you some problems. Hopefully you have those written down, and I kind of modified the directions. So what I gave you before, we had 25, 27. Those were listing information. I told you you had to do the amplitude, period, and the interval. Then 33, 35, 37, and 41. No, is that right? Yeah. Today I am going to add 1 through 8. Those are matching. 15 through 18. Those are also matching. And then 45 through 53 odd. I will allow you, if you want, on 45 through 53, a lot of those say 2 periods. If you just want to do 1 period, that's okay. You can do both if you want. My answer key has both, but I'm only going to require you to do 1 period on those graphs. And then you've got about 25 minutes right now to work and ask